Good afternoon.
Okay. So in the morning, we have studied about some basic things about the metals and non-metal, correct? So first we started with the properties of metal, then we shifted to properties of non-metal, then about some of the chemical properties of metals, like reactions with oxygen, reaction with the non-metals, and then we have studied about different behavior like acidic properties of metal oxide, basic properties of metal oxide, how it comes. So that we have studied. So the next part, we started with the extraction of metal. So when the metal is present, the metals will be available in the earth crust. From the earth crust, we need to extract the metal. So when we extract the metal, the earth crust will be having different forms of the same metal. So from the different forms of the same metal, we cannot extract the metals from all the different forms. For that, we need to, or we can extract the metal only from a particular mineral of the metal. That particular mineral of the metal from which the metal will be extracted, that we call it as a ore, and rest all other forms of the metals are called as the mineral. So we have two terms under that. One is a mineral and one more is a ore. So ore is a one from which we effectively extract the metal. And one more term which comes into picture during the extraction is the gangue. So when we consider a gangue, the gangue means the impurity which is present along with the particle, that is along with the ore, or maybe along with the. Now it is visible, Bhumika. Bhumika, you're there?
Yes, ma'am.
Now it is fine?
Yes.
Yeah, okay. So the impurity which is present along with the mineral or the ore, that we call it as a gangue particle. Next, what we have to do is we have to extract the metal from the ore. So ore will be the one from which the metal can be extracted profitably and economically. Profitably means when we extract the metal, the more percentage of metal must be extracted from the ore. That is a one condition. And one more, during the extraction, it should not produce any poisonous gases to the environment. We have to see both the factor. One is an environmental factor and one more is a profit of the company. Okay, so how we extract the metal? So metal will be extracted from their ore in three main steps. There are three steps which is common for all the metals to be extracted from the ore. The first step is concentration of the ore. So concentration of the ore means we are removing the gangue particle from the ore. The process of removing the gangue particle from the ore is called as concentration of the ore. The next is reduction to the metal, which means if the metal is available in the oxide form, then it has to reduce. Reduction means removal of oxygen. So from the metal oxide, oxygen must be removed so as to get the metal. Or if it is present in a carbonate form, then we have to convert it into corresponding oxide form first. Then we need to carry out the reduction. The same thing is applicable if it is present in a sulfide form as well as halide. So whichever form the metal is available or ore is available, first what we do is we have to convert that into oxide form. After converting it to oxide, we are carrying out a reduction so as to get the impure metal. After carrying out the reduction process, the metal which we obtain is an impure metal. And the last technique or the last step is the refining, where we are purifying the metal which is extracted from the earth crust or from the ore. So these are all the three different methods. All the ores will be having the impurity. So concentration is must. All the ores has to be converted into oxide form. Then it has to be converted, or it has to we have to carry out the reduction technique. The third one is refining. That is also required because impure metal we cannot use for all the purpose. So these are all the three different methods which is there for, or which we have to conduct for all the ores. So after this, so what is concentration? That is the process of removing the gangue particle. So next what we have to do is the different steps involved in the extraction of metals from the ore. So now these three steps we carry out. After that, what and all the methods we have to extract the ore. So basically, we start our process by taking the ore. The ore can be converted, or ore can be converted into different, or the different steps are there for the extraction. The one, if the ore contains the metal which is of high reactivity. So we have seen the reactivity series. In the reactivity series, if the metal is present at a high reactivity form, then we have to carry out different steps. If it is of medium reactivity, the steps are different. If they are of low reactivity also, the steps are different. So individual methods have different steps. So we study them one by one. First, we'll start with the metals of high reactivity. So for a high reactive metal, we have to carry out electrolysis of molten ore. High reactive means potassium, if we consider. Potassium is a high reactive element. So, or a sodium we can consider. So these are all the high reactive metals which are present. For that, we need to carry out the electrolysis technique. What is electrolysis technique? I'll explain you after this. Okay. After electrolysis, we have to get the pure metal. So this is the steps which are involved when the metals are high reactive. If the metals are medium reactivity, then also we have two methods. The one is if the ore is carbonate ore, if the ore is sulfide ore. So metals of low medium reactivity can have carbonate form of ore or a sulfide form of ore. If it is a carbonate form of ore, we have to carry out calcination. Okay, calcination means heating in the absence of air. We need to heat that ore in the absence or a limited supply of air. If it is a sulfide ore, for a sulfide ore, we need to carry out the roasting. Roasting means heating the metal ore in the presence of excess of oxygen. Okay, so after calcination and roasting, the metal will be converted into its oxide form. From the oxide form of the metal, then we have to carry out the reduction to get a metal, and from the metal, again, we have to do the refining. Okay, so if it is of medium reactivity, first we have to see which ore is it, whether it is a carbonate form or whether it is a sulfide form. If it is a carbonate form, we have to go for a calcination, that is heating in the limited supply of air or in the absence of air. If it is a sulfide ore, we have to go for a roasting, that is heating in the presence of excess of air. For both the techniques, after carrying out both any of these technique or both the techniques, we'll end up with the metal which is present in an oxide form. From that oxide form, then we have to carry out the reduction, then to a refining. The next is metals of low reactivity. So metals of low reactivity, most of them are present in a sulfide form. One second. Okay, so from the sulfide form or a sulfide ore, we have to carry out the roasting. ಅಣ್ಣ ಸ್ಕ್ರೀನ್ ಶೇರ್.
ನಾ ಕೋರ್ಸ್ ಮಾಡ್ಬೇಕಂತಲ್ಲ.
ಹಾ
ಮಕ್ಳೇ, ನಾ ಇನ್ನೊಬ್ರು ಯಾರು ಆದಿತ್ಯ ಇದೆಯಾ? ಆದಿತ್ಯ
ಸರ್
ಆದಿತ್ಯ, ನಿನ್ನ ಕೋರ್ಸ್ ಮಾಡಿದ್ದೇನೆ ಆಯ್ತಾ? ಯಾರಾದ್ರು ಲೀವ್ ಆದ್ರೆ ಎಲ್ಲೋ ಕೊಡು, ಇನ್ ಕೇಸ್ ಮ್ಯಾಮ್ ಲೀವ್ ಆದ್ರೆ.
ಓಕೆ ಸರ್, ಓಕೆ.
Okay, so from the sulfide form of low reactive metal, first sulfide ore will be carrying out a roasting process because we have to convert it into oxide form. Then again we'll get the reduction, that is oxide form of the metal will be obtained. Then we have to carry out the refining technique. So these are all the different forms we have based on which metal we are extracting. Okay, so if you are extracting a low reactive metal, the technique is different. If you are extracting a medium reactive metal, then it is different. And if it is of low reactivity, it is different. Okay, so we'll see one by one. So first we do the extraction of metals of low in reactivity series. So low reactivity will be present in a sulfide form. Okay, so first what we have to see, metals which are of low reactivity series can be reduced to a metal by heating in the presence of oxygen. That is, we need to carry out the roasting process. When we carry out the roasting process, for example, we have taken a low reactivity metal as a mercury. When a mercury, that is the ore of mercury called cinnabar with the formula HGS, by heating in the presence of oxygen. When it is heated in the presence of oxygen, it is first converted into mercuric oxide, and then by further heating, it is reduced to mercury. So what happens? First, the sulfide form will be carried out for the roasting. Roasting means heating in the presence of excess of oxygen. When we heat it in the presence of excess of oxygen, the sulfide form will be converted into oxide form. And from the oxide form, again, if we carry out the heating process, we will end up with the liberation of oxygen, that is reduction takes place, and that reduction gives us the metal, that is mercury. So once the metal will be extracted, then we have to go for the refining technique. Okay, so similarly, we can consider one more example of copper. So sulfide form, it will be present as a copper sulfide by heating in the presence of oxygen. When we heat it in the presence of oxygen, it will be converted into copper oxide, and along with that, sulfur dioxide will be present. And that copper oxide which is present again made to combine with the copper sulfide. So again, the same ore will be added so that that sulfur will remove the oxygen from the copper and we will get the copper. Okay, so first the sulfide will be converted into oxide. From the oxide, we have to carry out the reduction. Simple heating will not help us for the reduction technique. For that, we are using the ore again, that is copper sulfide ore again, that then combines with the oxygen which is present in a copper oxide and converted into sulfur dioxide, and we'll get the copper. So these are all the two different examples for the extraction of metals in the low reactivity series. So the metals of low reactivity series will be, most of them are present in a sulfide form. First, we have to carry out the roasting. Then again, the roasted metal, that is oxide form of the metal, will be again heated so as to get the metal. Sometimes heating is sufficient for the reduction. Sometimes we have to use the reducing agent. So in the case of copper, the reducing agent is required, whereas in case of mercuric oxide, the reducing agent is not required. So based on the metal which we are extracting, we need to use the reducing agent. So this is of extraction of low metal. Any doubt? Any doubt? Okay, we'll continue then. So next we have to see the Okay, so elements which are present in the, one second, anybody is having any doubt? Okay, so the extraction of metal in the middle of the activity series. So middle of the activity series means the one like zinc, iron, lead, they are found in the middle of the activity series. And these metals are available in oxide form, sulfide form, or a carbonate form. So we have seen the middle of the series. There are two forms, carbonate form as well as sulfide form. Carbonate, calcination, sulfide, roasting. So same technique we are using here also. So first what we have to do, we have to convert them into oxide form. Okay, so if it is present or the oxide form can be obtained if the metals are present in a sulfide or a carbonate form. Okay, so from sulfide form and from carbonate form, we need to convert into corresponding oxide form. And if it is already present in an oxide form only, no need to carry out the calcination or a roasting technique. Okay, so non-oxide forms or a non-oxide ores has to be converted into oxide form either by a roasting technique or by the calcination technique. So if we take a roasting means heating in the presence of oxygen. This roasting process will be usually used when the ore is present in a sulfide form. So from the sulfide form, for example, if I consider zinc sulfide, which is in the middle of the reactivity series, that zinc sulfide will be heated in the presence of excess of oxygen. When it is heated in the presence of excess of oxygen, the sulfide form will be converted into corresponding oxide form. From that, we have to then extract the metal. One more form of the metal we have in the middle of the activity series is a carbonate form. So if it is present in a carbonate form, then no need of oxygen for the heating or for the conversion of carbonate into oxide. At that time, what we are doing, we are converting the ore into oxide form. Direct heating is sufficient. For example, if I consider a zinc carbonate, then direct heating of the zinc carbonate gives us zinc oxide and carbon dioxide. So this is the two different oxides two different ores which has to be converted into oxide form. Sulfide to oxide, roasting, carbonate to oxide, calcination. So by heating, the carbonate, that is CO3, contains oxygen already in it. So that oxygen should be retained and carbon dioxide to be removed. The removal of carbon dioxide is easy. So simple heating is sufficient for the conversion of carbonate into oxide. Now, the oxide which is obtained either by roasting or a calcination is then reduced to metal by heating with the reducing agent. So then we have to use a reducing agent. By using a reducing agent, we need to convert oxide form of the metal into metal. Reducing agent means the one which helps in reduction, that is removal of oxygen. So the most common reducing agent used in this or for this ores are coke. Coke means it is a carbon. So carbon will be the most reducing agent. So zinc oxide, you can see the reaction. The zinc oxide which is obtained in both the steps, then heated in the presence of carbon. This carbon takes up the oxygen from the zinc oxide and becomes carbon monoxide, and the metallic zinc becomes free. Okay, so this can be done by using a reducing agent. So any doubt in this? Middle of the activity series? Any doubt to anyone? Okay, so the next one, we have to go for the, okay, before that, we have to see what is Termit reaction, which is also there. 1 second. Yeah, so what is Termit reaction? So reactive metals, that is the first series, the reactive metals like sodium, calcium, aluminium are used as a reducing agent to obtain metals from their oxide. Other than coke, the high reactive metals like sodium, calcium, aluminium, they can also be used to obtain the metal from their oxide. For example, manganese oxide, when it is made to react with aluminium, and in the beginning itself we have seen that more reactive metals displaces less reactive metal. Since aluminium is a more reactive metal, aluminium displaces or replaces the position of manganese, and aluminium become oxide form and manganese will be free. So what we get, the manganese we obtain, along with that aluminium oxide will be obtained. So using the more reactive metals for the reduction of less reactive metal oxide, that reaction is called as termite or reaction. Here, the high reactivity metal displaces low reactivity metal. Okay, so the reaction between the metal oxide and the aluminium is highly exothermic. Exothermic means heat is liberated during this conversion. And since the heat is liberated, or a large amount of heat is liberated, the metal will be obtained, that is manganese will be obtained in a molten state. That reaction is called as termite reaction. Okay, so the reaction between iron oxide and aluminium produces molten iron. So this reaction is used to join railway tracks, broken machine part, etc. So in a railway track, if the track is having any damage in it, then this reaction of iron oxide and aluminium will be carried out, so that the metal will be obtained in a molten form. And that molten form of the metal will be used for, or that will repair the track. So you can see the reaction, iron oxide, aluminium, replacement of iron by aluminium takes place, and aluminium will be free. Along with that, the large amount of heat will be liberated from the system. Okay, you can see the picture of the termite. So this is how the termite welds will be carried out. So here they are making the reaction of aluminium and the iron oxide, and the exothermic reaction takes place and will get the proper form of the molten iron oxide that can be adjusted in a different form which is required for us. So the next is the extraction of metals from the top of the reactivity series. So from the top of the reactivity series, as I already told, we are doing electrolysis technique. The most reactive metals like potassium, sodium, calcium, aluminium, any of them can be obtained from their ore by electrolysis technique. Okay, so because we cannot obtain, why we have to do the electrolysis process or electrolytic reduction? Because they cannot be obtained by heating or by using a reducing agent. For that purpose, we need to go for the electrolysis technique. So what we have to do? For example, when an electric current is passed through molten sodium chloride, so sodium chloride we have taken because we want to extract the sodium. Okay, the sodium metal will be deposited at cathode, and okay, you can see the reaction. So here, this process is called electrolysis, in which there is a container in which molten sodium chloride, that is melted sodium chloride, is taken, and two metallic strips are kept. 1, 2. One is connected to the negative terminal of the battery and it is called cathode. And one more is connected to the positive terminal of the battery and is called anode. So when a molten state of the metal is taken, in a molten state, sodium chloride is available in a Na plus and Cl minus form. that Na plus, since it has a positive charge, will be attracted towards the negatively charged electrode and moves there. Whereas the chlorine, which has a negative charge, which will move towards the positive electrode, that is anode, and it will be liberated. So what happens actually? So sodium, which is present in a molten state, goes near the electrode and their electrons are there and it will be deposited in the form of sodium. So sodium metal will be collected around this electrode. Whereas the chlorine, when it loses its electron, it becomes a chlorine gas. Cl2 gas will be formed. That Cl2 gas will be liberated at the anode, and this is the reaction takes place. And that sodium which is obtained is then collected and further the refining will be carried out. Okay, so these are all the different techniques for a different types of metal in the activity or the reactivity series. Maybe low reactivity, maybe high reactivity, maybe the middle of the reactivity series. Any doubt? Any doubt to anyone? Okay, fine. So we'll continue then. The last step, which is common for all the technique, that is refining. Now we have extracted metal in all the techniques, that is low reactivity, high reactivity, and middle. Now we have to go for a refining technique. So refining of the metals. So refining of the metal means removal of impurities from the metal to obtain a pure metal. That process is called as refining of the metal. And the most common method which is used for the refining is electrolytic refining. Electrolytic refining will be used. So in this method, what we are doing in electrolytic refining. So what we do is we have to take a block of impure metal, that is one strip or one rod of the impure metal will be taken, and always the impure metal will be made as an anode, which means that impure metal will be connected to a positive terminal of the battery. And a thin sheet of same pure metal. For example, I am carrying out a refining of copper. The copper in the impure form will be taken, and the copper in the pure form, that is small sheet of the copper in the pure form will be taken, that is made as a cathode. Okay, the electrolyte is a salt solution of the metal to be purified, which means if I am carrying out the electrolysis of copper, then I have to take copper sulfate solution in the container. Then I have to carry out the electrolysis process. You can see here. So this is a container in which we are carrying out the electrolysis. So this is a pure copper, and pure copper will be taken as the negative electrode, that is cathode, and an impure metal, that is the big rod of the impure metal will be taken, and that will be connected to a positive terminal of the battery, and it is called as anode. Then the solution in which the metal rods are dipped, that solution is a copper sulfate solution. Okay, so in a refining of electrolytic refining, a block of impure copper is taken as an anode and a thin sheet of copper is made as a cathode. The electrolysis of is acidified. Copper sulfate is taken as an electrolyte, and when electric current is passed through the electrolyte, now what happens? Once the battery is switched on, okay, the pure copper or the copper which is present in a metal strips comes out of the metal. It will be converted from Cu to Cu2 plus, and that positively charged Cu2 plus moves towards the negatively charged copper rod. So from the impure metal rod, the pure metal comes out of the rod and it will move towards the oppositely charged electrode and it will be deposited around this. And or whatever is there in the solution, that will be collected at the bottom. So this is how we can carry out the electrolytic refining technique. So by using the electrolytic refining technique, we can carry out or we can obtain the pure metal from the impure rod. Always the impure rod will be taken as an anode and pure rod will be taken as a cathode, so that the impure rod or from the impure rod, the metal will move into the electrolyte and then move towards the electrode, that is negatively charged pure copper sulfate, copper electrode, and it will be collected around this. And the mud particle or any of the impurity which is there along with the metal, that will be collected at the bottom. So this is how we can carry out the refining technique. Any doubt? Any doubt in a refining? Okay. The next, we have to see the corrosion. So you all know that most of the metals will be corroded. Okay, so corrosion happens for all the metals which are there except the alloys which are there. So we'll see what are alloys after this. Okay, so corrosion means what? Corrosion means damage which is caused to the metal. The damage will be caused because of the reaction of metal with the oxygen, moisture and carbon dioxide, etc., which is present in the atmosphere. When the metal is exposed to the atmosphere, the metal will be directly in contact with the oxygen, in contact with the moisture, and in contact with the carbon dioxide and other gases which is present in the environment. And these gases or the moisture which is present in the environment, that will damage the metal, and that process is, or that damaging of the metal by these atmospheric factors is called corrosion. Okay, so what happens in the corrosion? Corrosion means what? That is different in different method. For example, the iron. In case of iron, we'll call it as rusting of iron. That is, a brown coating will be deposited around the iron. And in case of copper, it is the green coating which is present. That is, a carbonate form of the copper will be deposited around the copper. Whereas in case of silver, the silver will be converted into a black color because of the coating of silver sulfide. So rust for iron, basic copper carbonate over a copper, and sulfide form of silver over a silver. So these are all some of the examples for the corrosion. And how the air and moisture, or why the air and moistures are necessary for the rusting of iron. So both are required or not, that we have to see. For example, to carry out the experiment, first what we have to take, we have to take the container. In the container, we have to take the anhydrous calcium chloride. Anhydrous means no water. Okay, so we have to take an anhydrous calcium chloride in one of the test tube to absorb the moisture. Okay, so first test tube, what we are doing, we are taking anhydrous calcium chloride so that it will absorb the moisture from the atmosphere. In the second test tube, we are taking boiled distilled water will be taken in a test tube too and pour some oil over it to prevent air into the test tube. So here what they did, here they have taken anhydrous calcium chloride. So water will not be there here. Air content will be there. But here they have taken water and the iron nail is dipped into it. But above the water, they have kept oil so that air will not come in contact with it. In the third case, okay, they have taken some water in the test tube and the cork of the test tube will be left as such, which means that in the third test tube, the nail is in contact with both water, moisture, as well as the environmental gases. And if we leave the 3 test tube as such for some days, it has been seen that the nail which is present in a first container remains as such, whereas the nail in the second container also remains as such, whereas the third container or third test tube which is in contact with both water and the air, that is rusted, which means this experiment shows that the rusting requires both air as well as moisture. Without air, only if there is moisture is present, no use. Without moisture, if only air is present, no use. If both air and moisture is present, then only the metal will be rusted. So necessary condition for the rusting is the air and the moisture. Okay, so that is about the corrosion. Any doubt? Any doubt in corrosion part? Okay, so the next what we have to see. Now we know how the corrosion takes place. Next, we need to see how we can prevent that corrosion. So anybody knows any technique for the prevention of corrosion? Any
Painting.
techniques? Painting, yes. In our home, what we do, the rods of the window, if there is a iron rod which is present, it will be painted. Yes, that is one of the technique. Then any
Oiling.
other technique? Oiling, because we have seen that if we do the oiling process, the air will not be come in contact with it. Okay, other than that, grease can be used, oil can be used. Okay, so we'll see what are all the methods which can be used for the prevention. Okay, the corrosion of the metals can be prevented by applying oil or a grease. When an oil is applied, the air cannot come in contact with the metal, as well as the water also cannot come in contact with the metal. The same is true in case of grease also. So we can apply the oil or we can apply the grease. The next one is by applying paint. Paint will prevent the metal to come in contact with the moisture and the air. The third one is by galvanization. Galvanization means coating the metal with the zinc. When we coat the metal with the zinc, the outer zinc will be corroded first, then the inner metal will be corroded. So outer zinc will give its life to save the inner metal which is present. That process is called galvanization, that is coating or putting a coating of the zinc around the metal. The next we can carry out, that is also tinning. Tinning means coating with the tin. Tin are less reactive, so that will prevent the inner metal safe, or that will prevent the corrosion. The next technique is electroplating. Electroplating means coating less reactive metals like chromium. The metal which is there inside, will be high reactive, whereas the coated one will be less reactive. Since the chromium is less reactive metal, that chromium itself does not undergo any kind of reaction with the atmosphere. If it itself does not undergo any kind of reaction, then the outer cover itself safe. If the outer cover is safe, the inner metal also safe. That is also one more technique. And the last one is by alloying. Alloying means by making or by converting metal into its alloy. How or what is that alloying means? So alloy means what? Alloy means it is a homogeneous mixture. Homogeneous mixture means complete mixing. For example, if you take a water, to that if you add sodium chloride, the sodium chloride will be completely soluble in water. Once the sodium chloride is soluble in water, can we separate the salt and water again? Can we see the salt in water? No, we cannot recognize that even we cannot recognize that there is a salt in water. So that is called homogeneous. One more word is there, that is called heterogeneous. Heterogeneous means the mixture of water and sand. The mixture which will not mix completely with one another. The one which mix completely with one another is called homogeneous, and the one which does not mix with completely with one another is called heterogeneous. So alloy means it is a homogeneous mixture of two or more than two metals, or maybe the mixture of metal as well as non-metal. Any of them we can consider. For example, we can consider steel. So steel is a mixture of metal and non-metal, that is iron and carbon. We use steel in our home, that is for households. We use for a household purpose, we use a steel. So have you ever seen the steel is corroded very easily? No, the steel container remains as such. The one more is a stainless steel, which is a combination of iron, carbon, cobalt, and nickel. That is a mixture of metal and a non-metal. The stainless steels will never be corroded. Next, it is a brass. It is a mixture of two metal, copper and zinc. Bronze, again two metal, copper and tin. And the solder is a one more one, which is a mixture of lead and tin. That solder or soldering will be used in welding of electrical wires. That is, you have seen that welding process. When we carry out the welding process, they go for the soldering. That soldering process, we call it as, or for that also we use the tin and the lead. Okay, so that is about the alloy. And if the alloy of two metals are formed, in that one of the metal is mercury, then that alloy we call it as amalgam. Okay, so if we take a mixture of zinc and mercury, it is called zinc amalgam. If we take copper and mercury, it is called copper amalgam. Tin and mercury called tin amalgam. So the word amalgam will be used if one of the metal in the alloy formation is mercury, then it is called amalgam. So any doubt in any part? So this ends your metals and non-metals chapter. So any doubt you have in any part? Whatever we studied from the morning, or whatever I have explained from the morning. If you have any doubts, you can ask. No doubt? Understood every part? So once go through the topic again. If you have any doubts, you can ask again in the next class or any of the classes, okay? Okay. So shall I end the meeting then? Shall I end the meeting? Okay, fine. See you.
ಏನ್ ಮಾಡ್ಲಾ?
ಹಾ ಅಣ್ಣ.